Okay, welcome to this second video on revenue, and here we're going to look at how we graph our revenue concepts. So firstly, what we have here is we have the situation for a price taker. A definition for a price taker is one that's basically it's got to accept the price that's being charged in the market by everybody else. Because it's so small, it can't actually affect the market price. So I've given you an example here. So we've got an industry in which there are 80,000 units being produced, and the market price, as determined by demand and supply, is £8. Now let's see what our small firm is doing in the market. So currently, let's say it's selling at £8 as well. It has to sell at the same price as everybody else. And it's selling 16 units. We can mark that little point there on the graph. So let's say it decides to double its level of output from 16 to 32 units. Let's see what happens on the demand supply diagram to the left. Well, imagine the supply curve shifting to the right by 16 units because this firm's put 16 new units onto the market. So if you look at that, then the quantity being supplied isn't technically 80,000, it's 80,016. We shift the supply curve to the right, and in fact, that shift is so small that you can't see it. So in effect, the market price remains unchanged. This firm can't affect the market price. It's true if all firms that were this size doubled their output, then we would see a shift in market price, but one firm on its own isn't going to affect the price. So let's put its new output and price level there, and in fact any output within the range of capability of this firm is going to give us just that same market price. They're not going to affect the price in the industry. So we can plot the demand curve that that firm faces as basically a horizontal line, because at a price of £8 it can sell as many as it wants, because that's the going rate for selling this product in the industry. So let's have a look at that on a table, and we can see it all set out here. So you can see the price is £8 at every level of output of the firm. The average revenue, as we said in the previous video, is the same as the price, because every time you sell a unit for £8, you get £8 revenue. So that works out well. And for the total revenue, if you remember, we multiplied the price by the quantity, and so we get our total revenue. So an output of 2, for example, it's 2 times 8, which is 16. An output of 8 is 8 times 8, which is 64, and so on. And you'll remember the definition of marginal revenue from the last video. So the marginal revenue is the change in total revenue when output changes by 1 unit. And that's why I've put the marginal revenue in between the outputs that we've plotted on the table. So we can see that when output goes from 0, which I haven't actually got on the table, to 1, total revenue becomes 8. So the marginal revenue there was £8. And that's the very first point that you can see that up here. So there's the marginal revenue as we increase output from 0 to 1. As output goes from 1 to 2, total revenue goes from 8 to 16, and the marginal revenue is 8. And unsurprisingly, that's going to be the same all the way through. The difference is always 8, because we're always selling an extra unit at £8. And so we can plot our total revenue. Okay, our total revenue at output 1 is 8, 16, 24, 32, and so on. It's going up by 8 each time. So here's our total revenue curve. And you'll see the gradient is constant. Every time we go across by 1 unit, we're going up by £8. That's a constant gradient of 8. And the gradient of the total revenue is in fact the marginal revenue. And the mathematicians amongst you might already be thinking, well, that means then that if we had an equation for the total revenue line, we could differentiate it to find out the marginal revenue, which would be correct. But you don't have to worry about that. That's far more complex than we need, but could actually be useful later on. So that's the situation for a price taker. A very easy diagram to draw here. It's one line on our axes showing both demand and average revenue and marginal revenue all at the going rate price of the market. So that's nice and easy. Let's complicate things a little bit now and look at a price setter. Okay, so here we have a firm that's so large now that its output decisions affect the market price. And in fact, on my diagram below, you can see I've basically monopolized the market. I said we now have one firm that can produce everything we saw before. So at a price of £8, it's producing all 80,000 units. So it can choose the price to set, and if it chooses a price, that'll affect how many it can sell. So for example, at a price of 8, it can sell 80,000. If it chooses a price of 6, it can sell 100,000. Or it can choose a quantity to sell. So if it decides they want to produce 100,000 for whatever reason, that means that they can only charge £6 and expect to sell them all. People sometimes say a monopoly can choose the price and output. Well, yes, technically, but basically it chooses one of those, and then the other will follow from the demand curve, what the industry will bear. Excuse me. So this is a little bit more complex in terms of the numbers than we need. So I'm going to simplify it slightly just by moving us into single units here. So we've got 8 being sold at £8 and 10 being sold at £6. Again, you can imagine it's 80,000 and 100,000, but this will just make our maths just a little bit easier. So what happens to our total revenue? Our total revenue remains price times quantity. So let's just do that multiplication. There we go. So we can see, for example, here output 4, the price is 12, and our total revenue is 48. Our average revenue is still the same as our price. So if we divide 48 by 4, then we are receiving £12 per unit. That's true all the way down. Yeah, so there we are, 10 times 6, 60, 12 times 4, 48. A brief audit there to show my maths is correct. What about marginal revenue? Well, this is going to be different. So when we have output 0 at a price of 16, let's say 0 times 16 is 0, so no total revenue. As soon as we produce our first output and sell it for 15, our revenue goes up by 15. But now look, our revenue goes up by 13, and then our revenue is going up here by 11, by 9, by 7. And incidentally, if we go the other way, okay, if we increase price, our revenue falls by 7, then by 9, then by 11. Okay, because this is a change in either direction when we change output by 1. So marginal revenue is not now the same as average revenue. And whereas average revenue goes down in steps of 1 as we increase output, 15, 14, 13, 12, 11, 10, 9. Marginal revenue is going down steps of 2, 15, 13, 11, 9, 7, 5, 3, 1, minus 1, minus 3. Yes, this can get negative. So in fact, the gradient of marginal revenue will be twice as steep as that of average revenue. And we can plot that there on our curve. So that's interesting in terms of marginal revenue and average revenue. So they now split up. What about total revenue? So that's the total revenue that we had before. Is it going to be the same? Well, we said the gradient of the total revenue was our marginal revenue, and previously our marginal revenue was constant. That isn't the case in this situation. So we can scrap that. What's our total revenue going to look like? Well, the marginal revenue, as we increase output, as we go along the bottom axis, our marginal revenue is going up, but by a decreasing amount each time. And at some point it reaches its maximum, and then total revenue is actually going to start to fall. So just have a think about what that curve might look like. And let's have a look. There we go. So we can see it's going up by a decreasing amount each time. We get to our maximum, and then total revenue is going to fall. Where is our total revenue at its maximum? It reaches its maximum where the marginal revenue stops adding to it, and then we'll start subtracting from it. On the diagram on the left, we can see that that occurs at an output of 8, and we can mark that on our total revenue curve there. At 8 units of output, that's where our marginal revenue is effectively going to be 0. So that's where we maximize. So I hope you find that useful. I've got one more video on revenue where we look at revenue and elasticity.